Hello friends, I am Dr. Chirality. I welcome you in my YouTube channel. Today in this video, I am going to talk about stereochemistry. So friends, what is stereochemistry? Stereochemistry is the study of the three-dimensional structure of molecules. It also defined as the branch of chemistry that concern with the three-dimensional arrangement of atoms and molecules and the effect of this on chemical reactions. You can see here. Now friends, isomerism. What is isomerism? The different compounds which have same molecular structure are called isomers, and the phenomenon is called isomerism. You can see here normal butane and isobutane. Classification of isomerism. Isomerism is structural and stereo. Structural isomerism contains chain, positional, functional, metamerism, and tautomerism. And stereo, geometric and optical. Now friend, structural isomerism, compound of the same molecular formula with different reactivity. Here you can see 2-methylheptane and 3-methylpentane. Stereoisomerism, compound of the same structure that differ in one or more aspect of stereochemistry. You can see here. Now conformational isomers, compounds of the same structure that differ in rotations around one or more single bond. Now I will talk about chiral and achiral carbon. Chiral carbon, a molecule containing a carbon with 4 different groups, results in a chiral molecule, and the carbon is related to as a chiral or a symmetric or stereogenic center. You can see here examples of chiral carbon. Now friend, properties of a chiral carbon. Chiral compound is a compound that is optically active and can rotate light. Although everything has a mirror image may or may not be superimposable. Actually, chiral molecules contains 4 different atoms by sp3 hybridizations. Chiral compounds are non-superimposable mirror image like our 2 hands. You can see here non-superimposable mirror image and demonstration with the hand. Now friends, a chiral carbon, a molecule or object that is superimposable on its mirror image is said to be a chiral. In a chiral molecule, carbon atom contains at least 2 same molecules on chiral ligand. You can see here. So now what is meaning of enantiomers? Enantiomers are the chiral molecules that are mirror images of one another. They have same physical properties, D-lactic acid and L-lactic acid. You can see here. Now diastomers. Diastomers are the stereoisomers that are not the mirror image of each other. D-glucose and D-galactose are diastomers. Now friend, geometric isomerism. Alkene shows geometric isomerism because it contains carbon-carbon double bonds which is unable to rotate. Now friend, geometrical isomerism in cyclic compounds. Cis cyclic compound, cis 1,2-dichlorocyclohexane is a chiral because the molecule has an internal plane of symmetry. Cis 1,2-dichlorocyclohexane is a chiral because the molecule has an internal plane of symmetry. You can see here internal plane of symmetry, sigma. Transcyclic compounds. Trans 1,2-dichlorocyclohexane does not have plane of symmetry. So the images are not superimposable and the molecules will have two enantiomers, not a plane of symmetry, enantiomers, different from the difference at left. You can see. Now asymmetric synthesis. Asymmetric synthesis may be defined as the chemical reaction in which stereoisomeric product is formed in unequal amounts under the influence of suitable optical active reagents. Optical resolutions method in the method of enantiomer separations. Generally, there are 5 types of optical resolution method: mechanical separations, biochemical separations, chemical separations, kinetic separations, and selective adsorptions. So, racemic mixtures. An equal amount of two enantiomers is called a racemic mixture. A racemic mixture is optically inactive. 50% D-tartaric acid and 50% L-tartaric acid mixtures. No rotations, you can see here. So mesocompound. Mesocompounds are a chiral compound that have a plane of symmetry. If one image was rotated 180 degrees, then it could be superimposed on the other image. RNS configurations. Both enantiomers of alanine receive the same name in the IUPAC system to aminopropanic acid. Only one enantiomer is biologically active. In alanine, only the enantiomers on the left can be metabolized by the enzyme. A way to distinguish between them is to use stereochemical modifiers R and S. Fischer projection. Flat representation of a 3D molecules. A chiral carbon is the intersections of horizontal and vertical lines. Horizontal lines are forward out of plane. Vertical lines are behind the plane. Fischer projection continue. You can see here. A specific rotation. A specific rotation is a standardized physical constant for the amount that a chiral compound rotates plane polarized light. A specific rotation is equal to alpha divided by L into C. Alpha observed rotations, L length of sample tube decimeter, C concentration gram per ml, and decimeter and 1 decimeter is equal to 10 centimeter. Optical activity. Enantiomers rotate the plane polarized light in opposite direction but same number of degree. You can see here D-lactic acid and L-lactic acid. Tautomerism. Tautomerisms are constitutional isomers of interconvert. These reactions commonly results in the relocations of protons, ketoform and enol form. Now, applications of stereochemistry. Stereochemistry has a significant role in pharmacy. It has importance into sectors such as medicinal importance. Dimethofen is a cough suppressant, but one metaform is a narcotics. Darvon is a painkiller, but its enantiomers is an anticoagulant. Biological importance. Now, this is the reference. Friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.